In 1943, the air war was dominated by propeller fighters, heavy bombers, and limited anti-aircraft defenses. In that scenario, a single F-22 Raptor would be an unstoppable weapon. Its supercruise speed is more than double that of any aircraft of the time. Its stealth technology makes it invisible to radar and alert systems of the 1940s. Its guided missiles could take down entire formations before the enemy understood what was happening. Neither the Luftwaffe nor the anti-aircraft artillery would have the capacity to respond. Each mission could destroy strategic targets in minutes: factories, trains, fuel depots, or entire squadrons of German fighters. The technological difference would be so great that aerial warfare would cease to have balance. To what extent could a single plane alter history? Could the Third Reich withstand, or would it collapse under total air superiority? Would it change the course of the Second World War? Iron Skies, German Supremacy in 1940. In the year 1940, German air supremacy was consolidated as one of the strategic pillars of the Third Reich. The Luftwaffe, officially created in 1935 under the command of Hermann Göring, had achieved accelerated growth in personnel, doctrine, and operational capacity. For military planners, air power was not an accessory element, but a central component of the blitzkrieg, conceived as a combination of speed, surprise, and precise coordination. The doctrine of blitzkrieg closely integrated armored units, motorized infantry, and air support. Its effects had been demonstrated in Poland in 1939 and in France in the spring of 1940. The use of aviation pursued two main goals: to ensure air supremacy to protect the land advance, and to use dive bombers or medium-range bombers to disrupt supply lines, destroy troop concentrations, and weaken fortifications. The Junkers 87 Stuka became the emblem of this tactic, used in precision attacks against specific targets. Its siren system added a visible impact effect on enemy troops, while aircraft like the Heinkel He 111, the Dornier Do 17, and the Junkers 88 offered sustained bombing capability against infrastructure and logistical centers. The Luftwaffe had started the war with several thousand aircraft in service, and within a few months was deploying thousands more on decisive fronts. During the initial campaigns, it mobilized hundreds of bombers and fighters, reaching numbers that far exceeded those of the Allied air forces. In May of 1940, as the offensive against France and the Netherlands began, the concentration of German air squadrons gave it numerical and organizational advantage that facilitated the quick defeat of its opponents. That superiority was not limited to quantity. The Allied air forces, dispersed and anchored in traditional doctrines, failed to coordinate with the same efficiency. The speed of the German results reinforced the perception that it was the most modern air force in the world. Even external powers like the United States or the Soviet Union were observing closely the coordination between aviation and the army that Germany demonstrated. The Heinkel He 111, originated in the 1930s as a passenger aircraft and converted into a medium bomber, constituted one of the central pieces of the German squadrons. Equipped with two high-performance engines, it reached speeds close to 500 kilometers per hour and carried bomb loads of up to 2 tons over medium-range routes. Its defense consisted of several machine guns installed in frontal, dorsal, ventral, and lateral positions. Although limited, its abundance made it the backbone of offensives, including its intensive use during the Battle of Britain. The Messerschmitt Bf 109 was the main fighter of the Luftwaffe. Designed as a metal monoplane with retractable landing gear and closed cockpit, it was at the technological forefront. In 1940, the Emil version, equipped with a Daimler-Benz engine of more than 1,000 horsepower, reached speeds greater than 500 kilometers per hour and a service ceiling of more than 10,000 meters. Its usual armament included 20mm cannons in the wings and machine guns over the engine, which provided it with great offensive capability. The autonomy was, however, its main limitation. With a range of action of less than 700 kilometers, the time available over enemy territory in the Battle of England was very limited, which compromised the prolonged escort of bombers. Despite this deficiency, its overall performance made it a feared adversary. The Messerschmitt Bf 110, designed as a long-range twin-engine heavy fighter, was conceived as a complement to escort bombers and attack enemy formations. Operated by 2 crew members, it had front armament composed of machine guns and cannons, plus a defensive machine gun for the co-pilot. Although it reached speeds close to 550 kilometers per hour and offered greater range, in practice it proved vulnerable against more maneuverable single-engine fighters. Its losses were high during the Battle of Britain, leading to a rethinking of its role. On the British side, the defence was based on 2 main models. The Hawker Hurricane, introduced in 1937, constituted the majority of available fighters. Equipped with a Rolls-Royce Merlin engine, it reached speeds close to 540 kilometers per hour and mounted 8 7mm machine guns. Although less agile than the Supermarine Spitfire, it was sturdy, easy to maintain, and effective against bombers. The Supermarine Spitfire, designed by R.J. Mitchell, featured an advanced design with elliptical wings that improved maneuverability. Its speed exceeded 570 kilometers per hour and, with the same Merlin engine, offered performance capable of balancing the confrontation against the Messerschmitt Bf 109. The combination of Hawker Hurricane and Supermarine Spitfire provided the RAF with a balance between endurance and agility essential to sustain the defence. The true British innovation lay in radar. The chain-home system, deployed on the coast, detected the approach of enemy formations and allowed for directing the fighters to the appropriate interception points. Although rudimentary compared to later versions, it transformed aerial combat by providing the ability for early reaction. Under the command of Marshal Hugh Dowding, Fighter Command organized a centralized air control system that maximized the available resources. Thanks to this detection and coordination network, the RAF could respond effectively despite its numerical inferiority. The combination of radar, efficient communications, and squadron rotation ensured operational continuity in the face of repeated attacks. British defensive strategies were based on preserving combat capability. They avoided unnecessary confrontations and applied the dispersion of resources to minimize damage. While the Luftwaffe sought to annihilate airfields and factories, the British resisted through conservation tactics and staggered deployment. The international image of the Luftwaffe as an unbeatable force was based on concrete results. In Poland and France, its air support had allowed entire armies to be dismantled in a few weeks. The use of bombings against industrial centers and cities represented a new level of total war from the air, which many observers considered decisive for the future of conflicts. The German air supremacy in 1940 was not only due to the quality of their aircraft, but to a doctrine that integrated all branches of modern warfare. Close support tactics, strategic bombing, and air superiority formed a coherent system. Their pilots, veterans of the Spanish Civil War, had acquired valuable experience that they were now applying in the European skies. The impossible visitor, the appearance of the Raptor in the war. On the morning of an ordinary day in the middle of 1940 over the English Channel, a German formation consisting of a Heinkel He-1 111 and 2 escort fighters, Messerschmitt Bf 109, was following a routine bombing route. The altitude was approximately 5,000 meters and the weather conditions were favorable. The commander of the bomber had received instructions to attack port targets on the southern coast of England. For the German crew members, it was yet another mission within the war of attrition campaign against the Royal Air Force. The formation maintained the usual discipline, the bomber in the center, the fighters flanking it at calculated distances to provide defensive coverage. The pilots of the Messerschmitt regularly scanned the horizon for British fighters that might try to intercept the mission. Without prior notice, the central aircraft of the formation became an explosion that did not correspond to any known projectile impact. The Heinkel showed no previous signs of fire or progressive damage. It simply disintegrated into a fireball that expanded in seconds, scattering fragments over a wide area of the channel. There had been no warning of approaching British fighters or visible impacts from anti-aircraft artillery. The escort fighters maneuvered immediately to search for the source of the threat. Their pilots applied standard combat procedures, tight turns to assess the airspace, climbs to gain altitude, and radio communications to report the contact. The crew of one of the Messerschmitt claimed to have seen a straight trail of fine smoke in the distance, followed by the bomber's detonation. They failed to identify any attacking aircraft in the vicinity. In less than 1 minute, one of the Bf 109 was hit by another explosion. The aircraft lost control immediately and plummeted toward the water in a descending spiral. The pilot did not have a chance to transmit emergency communications. The third member of the formation managed to keep his plane long enough to report that he had seen a metallic object cross in front of him at great speed. The speed of the intruder was too high to allow identification. Intelligence reports gathered vague descriptions with terms like metallic lightning and unknown machine. The last Messerschmitt executed evasive maneuvers and set course back to France, carrying with it the first account of what would become a recurring phenomenon over Europe. The explanation of this episode lay in the features of the F-22 Raptor, an air superiority fighter developed in the United States at the end of the 20th century and incorporated into service in 2005. The aircraft was powered by two Pratt & Whitney F-119 PW-100 engines, each with a thrust capacity of over 30,000 pounds. This performance provided a thrust-to-weight ratio greater than 1:1 and allowed it to maintain supersonic flights without afterburning. This capability, known as supercruise, reached speeds close to Mach 2, equivalent to about 2,450 km per hour. In contrast, the fastest fighters of the Luftwaffe, like the Bf-109E, barely exceeded 570 km per hour. The difference represented a technological leap of several decades in a single device. The operational ceiling of the F-22 exceeded 15,000 meters, far above the limits attainable in 1940. German fighters rarely exceeded 11,000 meters. This allowed the Raptor to move in airspace inaccessible to any plane of the time, with the ability to descend, attack, and return to safe positions in a matter of seconds. Its maneuverability was also far superior thanks to thrust vector control. This system, integrated into the nozzles, allowed redirecting the exhaust gases and performing tight turns impossible for aircraft with piston engines. The German pilots, trained under the flight physics of their time, had no frame of reference for understanding these maneuvers. The radar, an APG-77, was another element beyond the reach of the standards of 1940. It was an AESA radar capable of tracking multiple targets at distances greater than 200 kilometers. For the Luftwaffe, this meant that the Raptor detected enemy formations long before they could establish visual contact. The German doctrine, based on direct observation, was nullified against an adversary operating in an invisible information space. The armament of the Raptor reinforced these capabilities. It carried 6 AIM-120 AMRAAM missiles, capable of reaching speeds of up to Mach 4 with ranges of 100 kilometers. These missiles employed active radar guidance, which allowed the pilot to fire without needing to maintain visual contact. Additionally, the F-22 featured 2 AIM-9 Sidewinder infrared-guided missiles with ranges of more than 30 kilometers and speeds close to Mach 2.5. In close combat, it was equipped with an M61A2 Vulcan cannon of 20 mm, with a rate of fire of 6,000 rounds per minute. In operational terms, the destroyed German formation never had a chance to identify its attacker. The Heinkel He 111 was shot down from a distance far beyond the range of any airborne weapon of the time. The escort fighters, reacting according to established procedures, were eliminated sequentially without being able to locate the enemy. For the German pilots, accustomed to close combat and visual pursuit tactics, facing an adversary that attacked from invisible distances was inconceivable. The procedures designed for balanced confrontations were useless against an enemy that operated with unknown parameters. The reports of the survivors caused confusion among the Luftwaffe commanders. They mentioned devices that ascended vertically, soundless flashes of propellers, and maneuvers that no piston engine could perform. No testimony fully matched another, which increased the difficulty of analysis for the German intelligence. When the first reports reached Göring, the response was one of absolute rejection. The commander of the Luftwaffe attributed the testimonies to a lack of discipline and nervousness under combat. Hitler, informed through the general staff, reacted with the same disbelief. Convinced of the superiority of the German aviation, he ordered the bombings against England to be intensified. The intermediate levels of the Luftwaffe, on the other hand, showed greater concern. Technicians responsible for analyzing remains of downed aircraft found damage patterns corresponding to high-energy external explosions unrelated to known calibers. Some engineers suggested the hypothesis of an air-to-air rocket, although Germany was still years away from developing such a system. The psychological impact began to become evident among the pilots. The possibility of facing an invisible enemy undermined confidence in traditional tactics. Training based on aggressiveness, squadron coordination, and the Finger Four formation had no application against an adversary that attacked from invisible distances and disappeared at unreachable altitudes. The desperate hunt, the Luftwaffe against an invisible enemy. After the first inexplicable incidents over the English Channel and in areas of northern France, the Luftwaffe faced a situation that completely defied their conceptions of aerial warfare. The number of losses without visual contact with the enemy was steadily increasing, and the reports from the few pilots who managed to return agreed in describing an attacker impossible to classify within the known categories of aircraft. Hermann Göring relayed the reports gathered to Hitler, although he emphasized the absence of material evidence. Hitler, convinced that they were rumors intended to cover up deficiencies in discipline, issued a direct order: intensify the aerial deployments. The instruction consisted of sending more fighters on patrol and escort missions with the aim of locating and shooting down the supposed invisible enemy. This involved substantially increasing the use of the Messerschmitt Bf 109 and the Messerschmitt Bf 110. Larger formations were planned, with fighters covering at higher altitude and bombers surrounded by multiple defensive rings. The German commanders trusted that a greater number of observers and a higher volume of fire would allow them to identify the intruder and confront it with the conventional tactics of the Luftwaffe. The technical comparison between the Bf 109 and the F-22 Raptor illustrated the magnitude of the technological gap. The Bf 109E, the main operational variant in 1940, was powered by a Daimler-Benz DB601A engine with just over 1,000 horsepower. It could reach a maximum speed of 570 kilometers per hour and had an operational ceiling close to 11,000 meters. Its effective range was 660 kilometers, considerably limiting the time it could spend over enemy territory. In armament, the Messerschmitt mounted two MG-17 machine guns of 7 mm on the hood and two MG-FF 20 mm cannons on the wings. This configuration was enough to destroy contemporary fighters and bombers through precise bursts. In maneuverability, it was on par with rivals like the Supermarine Spitfire, although its narrow landing gear made it delicate during takeoffs and landings. The F-22 Raptor, in contrast, was equipped with two Pratt & Whitney F-119 engines with thrust vectoring, capable of generating more than 30,000 pounds each. With this power, it reached sustained speeds of Mach 2, equivalent to more than 2,400 kilometers per hour. Its operational ceiling exceeded 15,000 meters. The speed difference compared to the Bf 109 was almost 2,000 kilometers per hour, and the maximum altitude exceeded by several thousand meters the limits of any German aircraft. In maneuverability, although the Bf 109 was agile at low speeds, the vector control of the F-22 allowed for tight turns and changes of direction impossible for aircraft with piston engines. Regarding weaponry, while the German fighter relied on guns effective at less than 300 meters, the Raptor had AIM-120 AMRAAM missiles with ranges of up to 100 kilometers and AIM-9 Sidewinder infrared guided missiles for intermediate distances. The Messerschmitt Bf 110, conceived as a heavy escort fighter, was equipped with two Daimler-Benz DB601 engines that allowed it speeds of 540 kilometers per hour and a range of more than 1,000 kilometers. Its frontal armament consisted of four MG-17 machine guns and two MG-FF cannons, complemented by a defensive MG-15 machine gun. Despite its firepower, it was less maneuverable than a single-engine fighter and had already shown vulnerability against Spitfires and Hurricanes during the Battle of Britain. Compared to the F-22, the disadvantage was absolute. Its speed was 4 times lower, its operational ceiling was several thousands of meters below, and its volume made it an easy target. None of its weapons could match the range or accuracy of modern missiles. When the German squadrons began to fly in reinforced missions, the results remained devastating. The AMRAAM were launched from distances greater than 50 kilometers. The German pilots, without radars or early warning systems, were suddenly hit, often without ever having seen the attacker. For the Luftwaffe, conventional tactics based on visual sighting and close combat were useless. The few encounters where the F-22 approached at close distances ended the same way, with the immediate destruction of the German fighters. The M61, a 2 Vulcan cannon, with a rate of fire of 6,000 rounds per minute, could shoot down a Bf-109 or a Bf-110 fractions of a second. The differences in speed nullified any possibility of a response. Even the most experienced pilots found themselves unable to line up an effective shot. The German combat doctrine, designed for balanced engagements, became inoperative against an adversary operating outside of known parameters. In terms of losses, the figures accumulated quickly. On individual days, more than a dozen aircraft could be lost without the enemy suffering casualties. Attempts at encirclement maneuvers ended in chaos when missiles destroyed the formation leaders. The Bf-110, due to its size, suffered particularly severely, and its crews rarely had time to issue reports before being hit. The German commanders sought alternative solutions. Higher altitude flights were ordered to reduce the vertical advantage, but no plane could exceed 12,000 meters without compromising its performance. More dispersed formations were tested to avoid multiple casualties, although this reduced cohesion and left the bombers more exposed. Operating exclusively at night was even considered, but the German fighters lacked adequate instrumentation, and the adversary had onboard radar, which nullified any advantage of darkness. The technical reports still did not offer answers. The examined debris showed damage from external explosions with energy patterns unknown for the time. Some engineers speculated about air-to-air rockets, although Germany had not yet developed any operational ones. The hypothesis lacked a realistic technological basis for 1940. The impact on the pilots' morale was severe. The confidence instilled in the superiority of the Bf-109 and in aggressive tactics was eroding in the face of an adversary that seemed invulnerable. Entire squadrons began to show problems of discipline and an increase in accidents, visible signs that confusion was beginning to affect the Luftwaffe's operational capability. Precision strike, the F-22 turned into bomber. The F-22 Raptor had been conceived primarily as an air superiority fighter, but from the beginning of its design, air-to-ground capabilities were integrated, making it a multi-role aircraft. These functions gave it the ability to execute attack missions with a precision completely beyond the reach of any bomber from 1940. In a context in which Allied aviation depended on massive formations of heavy bombers escorted by fighters with significant range and accuracy limitations, the emergence of a single aircraft with precision bomber capability represented a fundamental shift in the established parameters of air warfare. The first distinctive aspect of the F-22 in its attack role was the ability to modify its load configuration according to the mission. It could carry up to 2 JDAM guided bombs weighing between 500 and 2,000 pounds, or alternatively up to 8 SDB bombs, each weighing 250 pounds. These munitions, developed for 21st century combat, were designed to exploit satellite guidance systems, but also incorporated inertial navigation to ensure accuracy even in the absence of a GPS signal. In the environment of 1940, when satellite guidance did not exist, the inertial system ensured much more accurate impacts than conventional bombings. The bombers of the Luftwaffe or the Royal Air Force had margins of error of hundreds of meters, which required multiple passes or large formations to ensure the destruction of strategic targets. In contrast, the F-22 could eliminate a precise target with a single bomb dropped from altitudes where no enemy defense could reach it. A JDAM bomb of 2,000 pounds doubled the power of the standard 1,100-pound bombs occasionally used by Germany in high-priority missions. Compared to the 500 or 250-pound bombs more commonly used, the difference was even more pronounced. These bombs could be released from altitudes above 12,000 meters, a height beyond the reach of both German anti-aircraft artillery and contemporary fighters. This practically reduced to zero the risk to the attacking aircraft and allowed it to repeat bombings without significant exposure. The SDB bombs, although less powerful individually, offered a distinct tactical advantage. Each one had aerodynamic surfaces that allowed it to glide up to 70 kilometers from the launch point. This meant that a single F-22 could attack 8 different targets in the same mission, releasing bombs on scattered targets without the need to fly directly over them. The concept of a series precision attack, with a single device eliminating multiple strategic targets in a matter of minutes, was non-existent in the military doctrine of 1940. At that time, bombers required tens or hundreds of planes to saturate an area in the hope of hitting designated targets. The F-22 could achieve equal or superior results with a minimum of resources. Among the most vulnerable targets were the armored convoys that crossed France. A JDAM bomb of 2,000 pounds could simultaneously destroy tanks, self-propelled artillery pieces, and supply vehicles concentrated in the same sector. The convoys, accustomed to attacks by conventional bombers that could be detected and evaded, had no procedure to face a precision attack from high altitude. The command centers were also priority targets. The Wehrmacht and the Luftwaffe operated from headquarters located tens of kilometers behind the front, facilities protected by fighters and anti-aircraft batteries. A single JDAM bomb dropped from a great height could penetrate a fortified building and destroy in seconds the communications and coordination capacity of entire divisions. The naval bases represented another target of enormous value. Ports like Lorient, Brest, or Wilhelmshaven, where the German submarines operated, could be neutralized with precise impacts on dry docks, bunker entrances, or maintenance cranes. A single SDB bomb could disable critical installations without the need for a massive bombardment. The airfields of the Luftwaffe were equally vulnerable. While at the time it required attacks with tens of bombers to damage runways or hangars, a single F-22 could destroy fuel depots, repair workshops, or main runways with precise ammunition. Although Germany was developing procedures to repair runways quickly, the repetition of surgical strikes limited their response capability. Even capital ships like the battleships Scharnhorst or Bismarck could be targets of the Raptor. With armor of up to 320 millimeters, these vessels were practically immune to aviation of 1940 except through joint operations with torpedoes and dive bombing. A JDAM bomb of 2,000 pounds, guided by inertial navigation to a vital compartment, had the capacity to sink a ship of this class with a single attack. Support operations for the Allies were also transformed thanks to these capabilities. Before the British or American bomber raids, the F-22 could neutralize anti-aircraft batteries, radar stations, and German airfields, thus reducing the pressure on the main formations and increasing their survival rate. During land operations, like an amphibious landing on the French coasts, the F-22 could employ SDB bombs to destroy bunkers, coastal artillery, and ammunition depots with direct hits from safe altitudes. This would have significantly reduced Allied casualties in the initial waves and accelerated the opening of beachheads. Unlike the fighter bombers of the time, which had to make multiple low-altitude passes and suffered high losses against anti-aircraft artillery, the Raptor dropped its bombs from unreachable heights with precision equal to or greater than that of the most effective dive attacks. This fundamentally changed the concept of close air support, eliminating the traditional compromise between precision and survival of the attacking aircraft. Weapons of the Reich, the secret projects against the impossible. As reports accumulated about the systematic destruction of aerial formations and German ground targets by an unidentified attacker, the Luftwaffe and OKW commanders began to seriously consider the possibility that the Allies had a completely new weapon. The difficulty in explaining the observed damage patterns, combined with the propaganda pressure to maintain the image of technological superiority, led Hitler to insist on the accelerated development of advanced weapons projects. Among these programs, the V-1 and V-2 rockets stood out, named by Nazi propaganda as Vergeltungswaffen, reprisal weapons. Originally conceived to attack British cities in response to the bombings on Germany, in a scenario where the F-22 Raptor operated since 1940, their development would have received additional priority as a possible means to neutralize the bases from which the intruder operated. The V-1, known as a flying bomb or buzz bomb for its characteristic sound, was the first operational cruise missile in military history. Designed in Peenemünde by Luftwaffe teams, It consisted of an aerodynamic fuselage powered by an Argus A014 pulse jet engine, allowing it to reach speeds of around 640 km per hour and a maximum range of up to 300 km. Its warhead carried about 850 kilograms of amatol explosive, a mixture of ammonium nitrate and TNT. The guidance system was extremely rudimentary. It used a gyroscope to maintain course and a distance counter based on a small propeller installed in the nose. When the programmed distance was reached, the engine stopped and the bomb plummeted onto the target area. The margin of error of the V1 could extend several kilometers, which made it useless against specific targets. It was only viable against entire cities or large installations. Additionally, its subsonic speed made it a vulnerable target. British fighters had already developed techniques to intercept it, and against a device like the F-22, the missile had no chance of success. The V-2 represented a major breakthrough. Developed under the direction of Werner von Braun in Peenemünde, it was a ballistic missile with a range of 320 kilometers and re-entry speed reaching Mach 4. It carried a payload of almost 1,000 kilograms of amatol and used a liquid fuel engine that combined ethyl alcohol with liquid oxygen, producing a thrust of 25 tons. It ascended to 90 kilometers altitude before following a ballistic trajectory towards its target. The V-2 was invulnerable to interception, but its accuracy was even more limited than that of the V-1, with errors of 10 to 20 kilometers. It could be used against large cities or industrial complexes, but it was ineffective against specific airfields. In practice, it did not offer a solution to neutralize the operations of the F-22. Furthermore, the historical development of these weapons did not reach operational maturity until 1944, and advancing it 4 years would have required diverting industrial resources that Germany could not afford. Meanwhile, the German anti-aircraft defense relied on conventional artillery. Among its most famous pieces were the Flak 36 and Flak 37 guns of 88 millimeters. Introduced in 1936, they had been designed as dual-purpose weapons, medium and high-range air defense, and anti-tank capability in ground combat. The Flak 88 guns were mounted on cruciform carriages that allowed them to be elevated up to 85 degrees. Their rate of fire was 15 to 20 shots per minute, and they could reach a theoretical altitude of almost 15,000 meters, although in real conditions the effective range against aircraft was about 8,000 meters. This figure was sufficient against Allied bombers operating between 4,000 and 7,000 meters, and by 1940 the Luftwaffe was deploying several thousand in defensive rings around cities, airfields, and industrial facilities. By 1944, the total number of Flak 88 exceeded 10,000 pieces in service, making up one of the densest anti-aircraft defenses in history. Against conventional bombers, these cannons were effective. Against the F-22, they were useless. The aircraft routinely operated at over 15,000 meters above the actual range of the projectiles. Even during air-to-ground attacks, it could drop guided bombs from altitudes inaccessible to German artillery. The reaction time of the cannons was insufficient to aim against a target flying at supersonic speeds. Furthermore, the guided munitions of the F-22 nullified the saturation principle on which flak artillery was based. A bomber from 1940 had to fly over the target for several seconds, exposing itself to concentrated fire. The F-22 could launch its JDAM bombs from tens of kilometers away and withdraw without risk. The probability of hitting such a fast and maneuverable aircraft with conventional projectiles was insignificant. While Allied bombers suffered significant losses crossing densely defended areas, the F-22 could attack the flak batteries themselves from safe altitudes, disabling key positions before they came within firing range. The concept of Wunderwaffe, the miracle weapons in which Hitler placed his trust, acquired an ironic nuance. The propaganda exalted projects like the Messerschmitt Me-262, the first operational jet fighter, the V-2, or the supercannon Gustav as symbols of German technological power. However, they all shared the inability to produce a real change on a large scale. The obsession with these weapons delayed pragmatic decisions and diverted resources to projects that could rarely be deployed in time. In this scenario, the paradox was evident. The F-22 practically represented what the Third Reich was seeking, a weapon so advanced it seemed miraculous. Its speed, operational altitude, relative invisibility, and bombing accuracy made it a true Wunderwaffe, but in the service of Germany's enemies. The German projects themselves, from the V-1 and V-2 rockets to the Flak 88 guns, did not offer any viable solution to counter it. The German reaction consisted of multiplying the production of retaliatory weapons and strengthening anti-aircraft artillery. However, these measures did not change the fundamental equation. The Luftwaffe continued to lose planes in asymmetric confrontations, and the Wehrmacht watched as strategic facilities were attacked with precision from altitudes and distances beyond their reach. Lone Predator, the real limit of an absolute power. The introduction of the F-22 Raptor in the context of 1940 represented such a radical technological leap that no contemporary weapon systems could face it with real chances of success. However, this absolute dominance in the tactical field did not mean by itself the ability to definitely alter the global course of the war. The operational effectiveness of any system depends not only on its technical characteristics, but also on logistical, industrial, and support factors that determine its long-term viability. The first fundamental obstacle was related to the fuel. The F-22 used JP-8, an aviation kerosene standardized by NATO in the 1980s, enriched with additives designed for high-performance jet engines. In 1940, there was no equivalent. The air forces of the time operated with high-octane aviation gasoline, typically from 100 to 130 octane, optimized for piston engines. Germany had begun experimenting with synthetic fuels through the Fischer-Tropsch process, but these products did not possess the necessary properties to power advanced compression turbofans. This meant that the F-22 depended solely on the fuel it carried at the time of its appearance. Once its reserves were depleted, there was no industrial infrastructure capable of producing a substitute. Its strategic autonomy was thus severely reduced. It could execute devastating missions in the short term, but not sustain continued operations. The ammunition represented another critical limitation. The AIM-120 AMRAAM and AIM-9 Sidewinder missiles could not be reproduced with the technology of the 1940s. Their manufacture required miniaturized electronic components, solid-state radar sensors, and infrared guidance systems impossible to replicate at the time. Each missile used was a non-renewable resource. Once the initial stock was exhausted, the F-22 would lose its long-range combat capability, which constituted its main advantage. Even the M61A2 Vulcan cannon depended on specific 20mm ammunition designed for a firing rate of 6,000 rounds per minute. The German or Allied 20mm ammunition did not meet the necessary standards of tolerance and resistance. Trying to use it could cause jams, premature explosions, or irreparable damage to the mechanism. Once the original ammunition ran out, the cannon would also become inoperative. Maintenance represented an even greater challenge. The F-22 required specialized and constant procedures to maintain its operability. Its structure was covered with radar-absorbing materials that had to be repaired with advanced chemical techniques, non-existent in 1940. The electronic systems, including the APG-77 radar, relied on semiconductors and integrated circuits irreplaceable at that time. A minor malfunction in the flight computers, the radar, or the hydraulic systems could leave it permanently grounded. The fighters of the time, on the other hand, were mechanically simpler and could be repaired at improvised airfields. A Messerschmitt Bf 109 with engine damage could be repaired by mechanics with basic automotive knowledge. The F-22, without access to specialized technicians or modern spare parts, was destined for inevitable degradation with continued use. These logistical limitations conditioned its real strategic impact. The Raptor could decide specific battles through surgical strikes, destroy entire air formations, or neutralize strategic targets with precision. It could accelerate the weakening of the Luftwaffe or reduce the operability of the Kriegsmarine in the Atlantic. But it lacked the capacity to sustain a prolonged campaign. Total war was based on mass production and global supply chains, something that a single device could not replace. The risk of becoming unusable after a few months was high. Each mission consumed irreplaceable fuel and ammunition. Each landing caused wear on materials and electronic systems that were impossible to maintain. With each operation, the probability of mechanical or structural failures that could not be corrected with the means of the time increased. On the psychological level, the presence of the F-22 had a double effect. For the Luftwaffe, it meant a progressive demoralization. The German doctrine relied on confidence in the superiority of its fighters and the skill of its pilots. Seeing entire formations destroyed without visual contact with the enemy undermined that confidence. Reports of pilots shot down without having seen their attacker fueled rumors about secret weapons impossible to understand. Among the Allied ranks, on the other hand, the existence of a device capable of executing precise attacks with impunity generated expectations of a quick victory. This was useful for internal morale and propaganda, but it implied a risk, overestimating the capability of a single resource compared to the industrial scale that really sustained the war. Experienced military commanders knew that the Raptor was an extraordinary tactical multiplier, but it could not replace entire armies or global supply chains. The true role of the F-22 was defined by this paradox. On the tactical level, it was a peerless predator, invulnerable in individual aerial combat and devastating in precision attacks. On the strategic level, it was a weapon limited by the lack of fuel, ammunition, and maintenance, destined to become a temporary disruptive element rather than a decisive factor. Its influence resembled that of an extraordinarily powerful opportunistic weapon, but incapable of independently altering the dynamics of a conflict involving entire continents and populations of millions of people. Broken history, the speculation of a future in the past. The contrast between a fighter like the Messerschmitt Bf-109 and the F-22 Raptor condenses in the same scenario a technological arc of more than 70 years. The Bf-109, introduced in 1937, was a metal monoplane powered by a piston-engine Daimler-Benz DB601, capable of reaching a maximum speed of 570 km per hour. Its armament consisted of 20mm cannons and 7.92mm machine guns with limited range and targeting systems based on optical sights. The F-22, incorporated into service in 2005, was equipped with thrust-vectoring turbofan engines, reached Mach 2 in supercruise mode, routinely operated above 15,000 meters, and had AESA radar, integrated electronic warfare systems, and missiles with ranges greater than 100 kilometers. The difference was not only in speed or power, but in nature itself. It was about systems based on aeronautical engineering principles that engineers in the 1940s could not even conceive. In the perspective of 1940, the Raptor would have been perceived as an incomprehensible artifact. Its silhouette without propellers, its accelerations at impossible angles, and its supersonic speed radically differentiated it from any existing aircraft. The leap was not incremental, as observed between contemporary models, but a complete break with the known technical fundamentals. For the pilots of the time, trained in tactics adapted to piston engines and propellers, facing an aircraft that changed course through thrust vectoring and maintained supersonic flights without afterburner would have been inconceivable. The basic principles of aerial combat, such as sustained turns or controlled dives, lost all value against an adversary that operated under unknown physical parameters. This contrast allows reflection on a central aspect of military history. Isolated technical innovation, no matter how revolutionary, does not guarantee victory in a total war. The Second World War was not decided solely in the skies or around the superior performance of a specific model, but in the Allied ability to produce en masse, sustain logistical chains on a global scale, and coordinate material and human resources on an unprecedented scale. The Luftwaffe, despite having advanced fighters like the Bf-109 and developing experimental projects, failed to compensate for the increasing logistical pressure and lack of resources. The occasional superiority of certain systems could not reverse the structural advantage of the Allies based on massive industrial production, continuous training of pilots, and the availability of fuel in sufficient quantities. The historical lesson is clear. Modern conflicts are defined both by the quality of weapons and by the quantity produced and sustained for the necessary time. The F-22, in the context of 1940, would have demonstrated undeniable immediate tactical power, but insufficient to replace the need for complete armies, factories, repair shops, fuel depots, and global transport networks. The fundamental limitation of the Raptor lay in its reliance on resources non-existent at the time. It required JP-8 fuel, guided munitions impossible to reproduce, and highly specialized maintenance. Even with spectacular air victories, the inability to sustain these operations limited its strategic influence to a brief phase of the conflict. The Second World War was largely decided by the Allied ability to continuously replenish losses, maintain industrial production despite bombings, and coordinate simultaneous operations in Europe, Africa, Asia, and the Pacific. This global dimension could not be replaced by any isolated innovation, no matter how advanced it was. The role of strategy and political decisions was equally decisive. The Luftwaffe had experienced pilots and competitive aircraft, but Hitler's decisions, such as the opening of the Eastern Front in 1941, and the dispersion of resources across multiple theaters, progressively weakened the German Air Force. A revolutionary weapon would not have compensated for strategic errors of that magnitude. Mass production underscores this contrast. The United States manufactured over 300,000 aircraft during the war, while Germany produced around 120,000. This difference translated directly into the ability to sustain simultaneous campaigns and replenish losses almost immediately. Against that scale, the presence of a single extraordinary aircraft did not alter the overall balance. History shows that advanced technology can modify specific battles or delay defeats, but it rarely determines by itself the outcome of a conflict involving entire nations. Examples like the Tiger tank, the Messerschmitt Me-262, or the V-2 rocket reflect superior innovations, but none altered the general course of the war. They were weapons too costly, produced in insufficient quantities, or introduced too late. The F-22 in that scenario would have generated an immediate imbalance in the European airspace. The Luftwaffe would have lost its superiority within weeks, and the Allies would have seen critical operations facilitated, such as the defense of Great Britain or subsequent landings on the continent. However, its inability to sustain indefinite operations, relying on non-existent technological resources, would have inevitably relegated it to a temporary role. The dynamics of conflicts also show that radical innovation generates adaptations. Germany would have accelerated projects like the Messerschmitt Me-262, the Heinkel He-280, or experimental air-to-air missile systems in search of countermeasures. Although without reaching a level comparable to that of the Raptor, the pressure to respond would have accelerated the technological race. This speculative scenario invites consideration of how history is defined not only by the available weapons, but also by the capabilities to sustain them, adapt them, and deploy them on an appropriate scale. The F-22 as a lone predator would have marked an immediate tactical imbalance, but total war would have continued to be decided by industrial, strategic, and political factors that far exceeded the capabilities of a single aircraft.